So anyways, continue further and look at unit vectors. So a unit vector is a vector whose length is 1. For instance, I, j, and k are all unit vectors. And in general, if the vector a is not equal to the 0 vector, then the unit vector has the same direction as a is. Yeah, but the 0 vector has no direction, it's just a point in space. Alright, so I'm going to write this out. So it has the length of 1. So in other words, if you have a unit vector u for a vector a, so let's say you have, so the vector a, you're going to multiply, you're going to divide this by, because you're going to scale it down by the length of that vector. So 1 over the distance of the length of the vector a times it by the vector a. So you're going to scale this down, so you're dividing it by its own length, so that it becomes a length of 1. Like that. So in other words, this equals to the vector a over the length of the vector. And here we could draw this out. So calculus book doesn't do this drawing, but I think it's pretty useful to do. So this is the just u, keep that in mind. So u, so basically we scale this vector, so you have it in xy. Move it here. So say you have it in the xy coordinates. This is x, y, and this is 0. And let's say you have u, or a is here. Let's say a is here. This is our a. Like that. Or let's make it longer here. So this is our a vector. Like that. And now if you divide by its length, or you scale it down by its length, you just get over here, where this length is 1. This is going to be our unit vector. And the unit and the length of this, so the length is equal to 1. Yeah, so this is just 1. Like that. Yeah, so I just put that 1, just saying it's a 1 distance across there. Or better yet, just put a dash line like this, dash, da, 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 da. So this length is going to be 1. So that's the unit length of that. And notice it's in the same direction as A. It's the same direction as A. Yeah, it's fascinating stuff. Alright, so now going further, so in order to verify this, that is this actually equals to 1 there, we let c scalar equals to 1 divided by the length of the vector a. So that you have this sign like that, bracket, the vertical columns, and then a vector. Then u, if this unit vector is equal to c, the scalar, times it by a, the vector, and c is a positive scalar, so u has the same direction as a. So it's positive, it's not negative. Because right here is the length here. This is going to be an absolute value sign. That's basically saying it's greater than 0. Greater than, it's greater than 0. So it's positive scalar, and so u has the same direction as a. So then also, so this it has the same direction. This is just a positive scalar. All you're doing is scaling it up further down or smaller, etc. So it's always in the same direction because it's a positive scalar. And also, and now here's where we prove it. So if we look at the distance or the length of the unit vector u, this equals to the length of the, just put these inside, ca. So this scalar times by this vector. And now this equals to the absolute value of c. That's, or just the length of the c, just a scalar. So then it's positive. And it's just going to be c like that, and then also times by a like that. So just factor that out, and then the c is equal to 1 over the distance, 1 over the length of a vector, and then times it by this right here, this a vector here, and these just cancel. This equals to 1. So you can just write it like that. Yeah, so basically the length of this c times a, where c is equal to 1 divided by, the length a, 1 divided by length a, this equals to length a divided by length a, this equals to, they just cancel. The lengths cancel, you're equals to 1, and we get this part right here, so check mark there. Alright, and now let's go further. Before that, let's just put a check mark here. So yeah, this check mark equals to this one, and so on. So example 6. So this states, find the unit vector in the direction of the vector 2i minus j minus 2k. So it's very interesting. Now we're asked to find the unit vector in this direction of this way. So the given vector has length, because we're going to need the length, and we're just going to multiply that by, we're going to divide this vector by the length, and we could just divide it each term and so on. So what we get is, yeah, the vector has the length, and you could write it in this notation, this absolute value sign, or just a vertical column. So 2i vector minus j vector minus 2k vector. So the length here is equal to, and in 3D, you just square the components. 2 squared plus -1 squared plus -2 squared. Like that. And this just equals 2. Well, 4 plus 1 plus 4. So -1 squared is 1. -2 squared is 4. So this equals 2. This equals 2. Let's put it here. This equals to square root 9. So you have 4 plus 1 is 5 plus 4. Or 4 plus 4 is 8 plus 1 is 9. This equals 2 and square plus or minus 3. But we're just going to look at the 3 positive. Like that. All right, there's, well, let's put into check mark. So that's 3 there. All right, so thus, by the earlier equation for a unit vector, the unit vector of the same direction is, so we just divide this by the length there. So unit vector is the vector divided by the length. In other words, you're multiplying it by a scalar. So the unit vector, you could write this as, the unit vector is equal to the vector divided by, so the vector is just there, 2i minus j factorial, not factorial, the vector, the arrow, minus 2k, like that. Then divide this by the length. So put this like this in notation, 2i with the vertical columns minus j minus 2k, like that. Let's make it a bit neater. Now this equals 2, and let's write this out. Yeah, this just equals to, well, this is 3. This is divided by 3. So in other words, you're just multiplying the vector by a scalar 1/3. So multiplied by 2i minus j minus 2k. Like this. And then you could, well, write this all out. So 2 over 3. Like this. 2 over 3i minus 1 over 3j minus 2 over 3k, like that. And now we could just box this out.